In this video lecture, we will see the implementation of simple linear regression in Python. So there are different types of regression model available. So we are interested for the first type, that is the positive linear relationship for the simple linear regression. So let's see over here that this is my scatter plot. From this three plot, from where I can draw a linear line. So you can easily recognize, you can easily find out that you can draw a linear line in the first plot, that is over here. From this scatter plot and from this scatter plot, you will come to know that there is no linear relation between the x value and the y value. So what is this? This is my advertising data set. That is my advertising.csv file. It contains the different columns like TV, radio and newspaper. So the advertisement through TV, that is the television, advertisement through radio and the advertisement through newspaper. So I am doing the advertisement through this three medium. Then what will be my sales? So over here, you want to predict the value of sales, that what will be your sales if you do the advertisement through television. So whatever the value you want to predict, that will become your dependent variable y, and the dependent variable y must have some linear relation with the variable x. So from this three columns, that is the TV, newspaper and the radio, you can identify over here that the TV and the sales have linear relation between them. Over here, this is my fuel consumption CO2, that the data set we are talking about, that is my car data set. Over here, I have plotted the scatter plot of the three different columns, that is the engine size, cylinders and the fuel consumption comp. So these three columns has some linear relation between them. All other columns does not have a linear relation between them, so I have not plotted the graph for them. So how you can identify this? You can identify it by doing the trial and error. You can plot the graph for the various different columns and you can then identify that who has the linear relation between them. Over here, now the question is, in some data set, it might happen that two different columns does not have any kind of linear relation between them. All the columns are plotting the graph like this. Then what to do in such cases? So there are various machine learning algorithm available, just like logistic regression is there, then classification is there, clustering is there. Then for your data set, which machine learning algorithm is most suitable, that you have to find out. So over here, I have a linear relation between the two different variables. So I'm using the simple linear regression model. Or you can say that we have to study the simple linear regression model. So I have selected the data set which contains the linear relation between the two different columns. So what is this? This is my fuel consumption CO2.csv file. So this CO2 emissions will be my dependent variable, that is my y. And from this three, I have to select only one variable as the independent variable x. Because my equation is y equals to mx plus c. So from these three variables, I have to select only one variable as my value of x over here. So in place of y, I will write CO2 emission, and in place of x, I will write one column from this. So from these three columns, I will consider as my column x. So this is my scatter plot. I will decide it from this. So this is my engine size, cylinders and the fuel consumption comp. So I am finding this engine size as the most suitable one. You can also take cylinders and the fuel consumption comp in your case. But I am selecting over here the engine size. So I will make this engine size as my variable x over here. So now I have the value of y, I have the value of x. Now I want to find the value of m and the value of c. That is my intercept and my slope. So how this linear regression model is useful? Suppose these are my data set of a car manufacturing company. They have already manufactured so many cars. So these are the data that what is the engine size, what is the cylinder, and what is the CO2 emissions. Based on that data, we have trained our model and we have predicted this value. Now, the company is going to manufacture a new car. So this car is under process. So they have designed the car that what should be the engine size in the car, what should be the cylinders in the car, what should be the fuel consumption comp in the car. So this data I am having. Now I want to predict the value of CO2, that is the carbon dioxide emission. As the pollution is increasing day by day, so it is very necessary that you identify what is the carbon dioxide emissions is there in your car. So I'm getting the value as 236. So where this value comes from, it is the predicted value. So this value is predicted by the linear regression model. So let's see implementation part. So we will see over here the simple linear regression for the fuel consumption.csv file. First of all, I am importing all the needed packages, that is my matplot library, pandas, and the numpy. Then I am reading my data. It is my .csv file. So I am using the pandas function as read_csv. And I am writing df.head. So this head function will print only the first 5 rows. Make sure that in your df object, that is your data frame object, your complete data set is present. So in my data set, how many rows are there? I have 1068 rows. So in my this particular df object, there will be 1068 rows. But you are just printing first 5 rows over here for the display. Now the first step in the simple linear regression is the explore the data, and the second step is derive and analyze the descriptive statistics. So this is my first step, that is the explore the data, and my second step is derive and analyze the descriptive statistics. So over here I have combined both the steps. So I'm exploring the data, that what type of data is present in my data set, that it contains the data related to the car. Over here, I am summarizing the data. So for that, I am using the describe function. So I am writing df.describe. What this describe function will do, whatever the quantitative variables are there in my data set, so it will count the different values like what is the mean, minimum value, maximum value, and the standard deviation. You can see over here, I have performed the describe function on my df dataset. So it shows me count as 1067. So my total number of rows are 1068, but my first row, it contains the column header. So they are not counting this particular column header. They are counting the values from this one. So they are giving me the count as 1067 because this many rows are present in your dataset. Now I want to explore some features. So from different features, I'm interested for only 4 features, that is the engine size, cylinders, fuel consumption comps, and the CO2 emissions. And whatever my data is present in my df, that is my df object, I'm selecting all these 4 rows and I'm storing in my new object, that is my our_df as my object name. And I'm just printing the first 9 rows from my this object, that is my our_data frame. So it will print just the first 9 rows from my data set. But actually my this particular object contains the total number of row count as 1067. Now over here I am plotting the graph, that is my scatter plot. And for that I am using the Seaborn library and I am writing SNS. Where this SNS came from? It came from here. So I am writing sns.parplot. As in first argument, I am passing my object. So my object is our_df. On the x-axis, I want the variables, that is the engine size, cylinders, and the fuel consumption comp. So I am writing x variables equals to this 3. I am passing it as a list. So I am writing in the square bracket. On the y variables, I want only one variable, that is the CO2 emission. I am providing height equals to 4 because there are total number of 4 columns. aspect you have to give it as 1 and which type of graph it is. It is the scatter plot. So a such kind of scatter plot will be plotted. So all this point indicates 1067 different blue points. So from this 3, I am taking this engine size as my variable x because I want to draw a linear line on this graph. Now the next step in your SLR is the pre-process the data. So for pre-processing the data, you have to check whether the missing value are present in your data set or not. If the missing value is present, then you have to treat that missing value. You have to remove that missing value. Over here, I am checking that pd.isNull. This isNull function is used to check the missing value in your data set. So in which data set you want to perform? My object name is our_df. So it gives me all answer as false. It means there are no missing value present in my data set. Now moving on to my next step, that is my define functional form of the relationship. So over here, I am selecting the engine size. So it has the linear relation. So I am taking the variable x as our_df and I am selecting the engine size column and I am giving it as variable x. I am selecting CO2 emissions from my data frame and I am giving it as my variable y. Now I want to split my data set. So we have seen already in the previous video lecture that for splitting the data in Python, which library is used? sklearn library is used. So these all are the machine learning libraries. It is used to perform some kind of operation related to the machine learnings. So in that I am using this function, that is the train test split. So I am writing xtrain y-test, xtrain x-test, y-train y-test as my variable, and this train test split as my function. I am providing the value of x and y. So from where this value of x and y comes from? It comes from here. That is my value of x and y. So this my value of x and y is provided. I am giving the train size as 80%, test size as 20%, and it will take my data set different rows randomly. So this 4 variables will be allocated and it contains now some value. So over here, let's now take a look at the train data set. So this is my variable, that is x_train, and I'm writing x_train dot head. So what the head function will do, it will just print the first few rows, that is the first 5 rows. And you can see over here that this is my row indexes, that is 404, 531, 463 and so on. Then you can see over here that this my row indexes are chosen randomly over here. This is my Excel file. In this data set you can see this is the row index having the position as 4. This is the row index as position as 18. This is the row index as position as 736. But over here it is taking the rows randomly. So I'm printing the x_train dot head and I'm also printing the y_train dot head. Then you can see over here that whatever the row is selected for the x train, the same index row is selected for the y train. That is 404, 531 and so on. So it is taking the complete row for the x train and y train and the complete row for the x test and the y test. Now you can also plot the scatter plot like this, that is the plt.scatter, x train and y train. On the x-axis, I am giving the label as engine size. On the y-axis, I am giving the label as CO2 emissions. And I am writing plt.show. So this scatter plot is same as the scatter plot over here. And you can see over here, these are the 2 different dots. It shows the 2 different dots over here. Now this is my x and y. This is my scatter plot related to my train data set. So this is my x train and y train over here. So it contains only the 80% of the data and based on that 80% my scatter plot is plotted. Now again I am plotting the scatter plot using the x test and the Y test. So you can see over here the data points are comparatively low compared to this train one, because this is my 80% data set and this is my 20% data set. So obviously my blue points will be less compared to my train set. Now the next step in your simple linear regression model is estimate the regression parameters. We have defined the functional form of the relationship, that what is the linear relation between the two columns. So we have selected the engine size and the CO2 emissions. Now we want to estimate the regression parameters. So for that we will be using the ordinary least square method, that is the OLS, is called as the ordinary least square. So for performing the estimation, or we can say for building a linear model, we will be using the states model library. So I am writing over here import states model.api as sm. My equation of line is like this, that is y equals to mx plus c. I can also write like this, that is y equals to c plus mx. I can also write like this, that is c as b0 and m is b1. So these are my coefficients. This is my coefficient of x and I will call it as the slope and the intercept like this. So in the place of y, I will be writing CO2 emission. In the place of x, I will be writing engine size for this equation, that is y equals to mx plus c. So for the x value, I have to add some constant. So for adding the constant, what is the syntax? We have already seen in the previous lecture. So I am writing sm. Where this sm comes from? It came from here. That is my states model library. So I am writing sm.add constant. I am adding a constant to the x string. And I am storing it in my new variable, that is x underscore train underscore sm. And for fitting the regression line, for training the model, which function we are using? We are using the dot fit function. We have already seen this syntax in the previous video lecture. So I am writing sm.ols as my method. I am providing the first argument as my y, the second argument as my x, which contains the constant, that is my x underscore train sm. And I am fitting a line that will be stored in my object lr. I am printing the different parameters of the LR. So what this function will do? I have the value of y, I have the value of x. I want to calculate the value of m and the value of c. That is my slope and the intercept. So when I am writing LR dot parameters, so it will print the parameters like this. So it will tell that value of constant is 124 and the slope value is 39.369762. Just for the reference purpose, I am printing the summary, that is lr.summary. So it is telling me the summary as it is the ordinary least square regression model. So the dependent variable is CO2 emission, model used is ordinary least square. This is the r squared value, that is the 0.76 and so on. So this shows the different values for the different observations. Over here, I have the equation like this, that is y equals to mx plus c. I have the value of y, I have the value of x. Now what is my value of m and c? That is 124 and 39.36. It came from here. That is the 124 and 39.36. So I am plotting, I am writing over here the value of slope as this and the intercept as this one. Now I am writing like this. I am writing the scatter plot, that is plt.scatter. On the x-axis as the value of x train, on the y-axis as the value of y train. And I am writing plt.show. Then it will show me the scatter plot. So let's import the matplot library first. So I have imported the matplot library. Now I can plot the scatter plot like this. Now on this plot, I want a linear regression line. So for that, I will be using the equation like this, that is plt.plot. On the x-axis, I want the x train. On the y-axis, I want the value. So what is my value of y? So instead of y, I can write like this, that is mx plus c. So I am writing 39.3697. Engine size is my extreme. So I am passing extreme plus 124.671690. And I want the line as red. So I am writing the value as R. Then you can see over here that my linear regression line is plotted like this. Now I have trained my model. And using that training data, I have plotted my this particular linear regression line. Now I want to test a model. So I have to do the predictions of the CO2 values on my test set. So for the test set, again I have to add a constant on the x test. So I am writing sm.add constant x test, and I'm storing it in my new variable, that is x underscore test underscore sm. Over here, for testing the data set, which function we will be using? We will be using the predict function. For training, we will be using the dot fit function. So I'm writing LR. From where this LR came? This LR came from here, that is my training model. So whatever my training model is fitted and it is present in my variable or my object, you can say as LR. So I'm writing object name, that is LR.predict, and I'm passing the value of x. So you all know that for the prediction, you have the value of x and the value of y you have to predict. So over here, I'm just passing the value of x. For the fit function, you have to provide both the values, that is x and y. For the predict function, you want to predict the value of y, so you only have the value of x. So you are passing the value of x as an argument, and you will be getting the value of y predict. I'm printing the value of y predict. So what is this? This is my predicted value of y. So from the presentation, we will see this is my predicted value of y. This value is already present in your data set. Using the model, I have predicted this value. So it shows my predicted value of y. So this is my predicted value of y. Now I am performing the test. So for testing, we will not be using the difference of error. We will be using the mean squared error and the R2 score. So I want to find out the error. So always the error is found between these two values. That is my actual value, which is present in the data set. That is my actual value of CO2 emissions, and this my predicted CO2 emissions. So this value came from the model. This is the actual value. So always if I want to find the error, then I have to compare these two values, that is my y predict and my actual y value. So over here it is written like this, that is my mean squared error. I am giving y underscore test and my y predict. So what are these two? This is my y underscore test and this is my y underscore predict. So it is giving me the value like this, that is the 28. For the R squared, or you can say the R2 score, again you are finding out the accuracy, that how accurate your model is. So your model is 0.77% accurate. Over here, you want to visualize the fit on the test set. So you are writing the scatter plot, that is x test and the y test. For viewing this red line, you have to write the code, that is plt.plot. X test, for the value of y, you are using the equation, that is mx plus c, and you are passing the value of x as x test, and you want to view the line as red. Suppose over here I want to view the line as green, then you can write g like this over here, then you can view the line as green like this. So this is how the implementation of linear regression in Python works. You don't have to remember all this code, but make sure that where to change the code. So I am providing you this particular advertising.csv file. So you have to perform the coding related to the simple linear regression. I will be providing this IPYNB file for the fuel consumption CO2.csv file. So you can view the code. In this code, you can load this particular data set, that is my advertising.csv data set. You can view the pair plot. From this pair plot, you will take TV as my x variable and sales as my y variable. So on the x variable, you will take TV, y variable as sales. So your equation will become like this. That is my sales equals to 6.9 plus 0.05 into TV. So this is my value of x, and this is my intercept and the slope. So keeping it till here, thank you all.